This is a pre-built version of the application. So if I go ahead and run it, and if we want to add two matrices, then both must have the same size, and we add elements in the same position. So matrix 01 and matrix 02 have the same size, and what we do, we add -1 and -3 gives us -4, and 1 and -2 gives us -1, etc. until we get to 1 and 3, and this gives us 4. And subtracting is the same thing. So both matrices must have the same size, and we subtract elements in the same position. So if we want to subtract matrix 01 minus matrix 02, so -1 minus -3 gives us 2, and 1 minus -2 gives us 3, etc. And multiplying two matrices, then both must have matching inner dimension, and the size of the resulting matrix is obtained by dropping the middle dimensions. So we have here matrix 03 and multiplied by matrix 04. So matrix 03 has a dimension of 2 by 4, so 2 rows and 4 columns, and matrix 04 has a dimension of 4 by 3, 4 rows and 3 columns. So 2 by 4 and 4 by 3, if we drop the 4, then the resulting matrix will be a 2 by 3, and this is 2 rows and 3 columns. So we multiply row 0 by column 0, so -1 times -3, we add to that 1 times 4, and we add to that -1 times 1, and we add to that 1 times 4. So this would give us 10. And row 0 times column 1, so -1 times -2, and we add to that 1 times 1, and we add to that -1 times -2, and we add to that 1 times 0, and this would give us 5. And same thing, row 0 times column 2, this would give us 1, and then row 1 times column 0, so 2 times -3, and 1 times 4, and we add to that -2 times 1, and we add to that 1 times 4, and this would give us 0, etc. So this would be the resulting matrix. Now if we want to add a number to the matrix, for example here adding 5, this is a scalar operation, and it is applied to each element in a matrix. So we go -1 plus 5 gives us 4, and 1 plus 5 gives us 6, etc. till we get here 1 plus 5 gives us 6. And a scalar subtract is the same thing. The operation is applied to each element in the matrix. So here we're doing matrix 0, 1, minus 5. So minus 1 minus 5 gives us minus 6. And 1 minus 5 gives us minus 4, etc. And a scalar multiply, this operation is applied the same thing to each element in the matrix. So matrix 0, 1 times 5, so minus 1 times 5 gives us minus 5, and 1 times 5 gives us 5, etc. And a scalar divide operation is also applied to each element in the matrix. So matrix 0, 1 divided by 5, this will be minus 1 divided by 5, which will be minus 0.2, and 1 divided by 5 is minus 0.2, and etc. until 1 divided by 5 is also 0.2. I will start by creating a new project. And this will be running on Java 8. And here I will have a matrix class that will be in this package. And a driver class with a main method, and this class would demo the matrix operations. Now the data for a matrix will be contained in this two-dimensional array, and we can add a number to a matrix, or subtract a number from a matrix, or multiply a matrix by a number, or divide it by a number. And we call those scalar operations because the relative values of the elements in the matrix do not change. Only the scale changes. And we will have a get method for the data, which will be initialized in the constructor. So we're passing it this data, that ends up populating our data. And this method will handle the scalar operations. So scalar operations, it takes in the number to be added or subtracted or multiplied or divided, and the scalar operation, so that would be either add, subtract, multiply, or divide. And we return a new matrix after performing that operations. So the return data, the row and column, will be the original data plus x, or the original data minus x, or the original data times x, or divided by x. Next, if we want to add two matrices, we'll have this method that adds this passed in matrix to this matrix and returns a new matrix. For now, let's just return null. And we can subtract this passed in matrix from this matrix and return a new matrix. And for now, let's just return null. And we can also multiply this passed in matrix by this matrix and return a new matrix. And same thing, for now let's just return null. And I will have the toString method print the contents of this matrix. So the columns are labeled C0, C1, C2, etc. And the rows are labeled R0, R1, etc. And to add or subtract two matrices, they must be the same size. If they are not, I will throw this exception. And subtracting is the same as multiplying the passed in matrix by -1 and then doing an addition of the resulting matrix to this matrix. And going back to add, this code will add the elements in the same position for the two matrices and return a new matrix containing the results. And to multiply two matrices, they must have a matching inner dimension. If they don't, then I will throw this exception. And this code will perform the multiplication of the passed in matrix by this matrix and return a new matrix containing the result. So those are the operations that I want for now to implement in this class. Next, let's go to the driver class and let me define those four matrices that I will be using to test the various operations that we implemented here. So this code will be doing that. So let me go ahead and test run it. And here we go. So adding two matrices and subtracting two matrices and multiplying two matrices, doing scalar operations, addition, subtraction, multiplication and division.